In this video, we'll be going over the composition of functions. So here's a definition. When the output of one function is used as the input of another, we call the entire operation a composition of functions. For any input x and functions f and g, this action defines a composite function, which we write as f circle g, such that this. So how we read this is the left-hand side, oftentimes that's read as f circle g, and then the right-hand side is f of g of x. Okay, so either way, typically when we write a composition function of functions, it's going to be written in this form, f circle g. So what does a composition of function means? The gist of it is that we evaluate one function, and then whatever we get as the output of that function, we then input that into a second function. So it's kind of like evaluating two separate functions in a row. So we're going to look at this evaluation process on a table, graphically, and then algebraically. So let's look at a table first. So we have two different functions, the f function and the g function. Okay, we don't know what the algebraic representation of these functions are, but that's okay. So what this table is showing is when we put 1 into the f function, we get 6. When we put 1 into the g function, we get 3, and so on. So each row is showing what happens when we put in different x values into each of these functions. So let's do a couple different evaluations. Let's first do f circle g of 3, and then let's also do g circle f of 4. So this first one, f circle g of 3, how we can think of that is f of g of 3. And so what this means is we need to evaluate g of 3 first, and then whatever we get, we're going to input that into the f function. So g of 3, we're going to go down to 3, and then in the g function, when we put 3 into the g function, we get 2. So this 2 is going to go in right here. So the last step here is now we're going to say f of, in place of g of 3, we're going to place 2. So when we put 2 into the f function, we get 8. Okay, so when it's all said and done, we could say f circle g of 3 is equal to 8. Similarly, g circle f of 4, how we can think of that is g of f of 4. So evaluate f of 4 first. So go down to 4. For the f function, we get 1. And then we're going to input that into the g function. So whatever the output is for f of 4, we're going to input that into the g function. G of 1, go over to 1, and then in the g function we get 3. So when it's all said and done, we're going to say g circle f of 4 is equal to 3. Now let's look at a composition of functions where we have each function represented by a graph. Again, we aren't given the algebraic equation for each of these functions, although we could probably figure that out. But let's just go off of the graph. So first of all, let's find f circle g of 1, and then let's do g circle f of 5. So again, f circle g of 1, we can think of that as f of g of 1. So we're going to evaluate g of 1 first. So in the g function, which is on the left, we're going to go to an input value of 1, and the output we get there is 3. So g of 1 is equal to 3, so then let's evaluate f of 3. So now we need to go to the function on the right, which is the f function. Go over to 3, trace it up, and that's 6. So f circle g of 1 is equal to 6. The next one, we're going to do g circle f of 5. So g of f of 5. So f of 5, let's erase f of 5 we have right here, so that's going to be 2. So the inside part of that function is 2. So we're going to evaluate g of 2. So in the g function, we'll go over to 2, and that is equal to 0. So when it's all said and done, we're going to have g of f, oops, let's write it with the circle, g circle f of 5 is equal to 0. Let's do one more here, because we may see something like this. Let's do g circle g of 5. So what this means is g of 5. So we need to evaluate what g of 5 is. G of 5 looks like it's going to be 3. So that inside part of the composition is 3. So now we're going to figure out what g of 3 is. So we're just back in the same function. So g of 3 goes down to -1. So when we compose a function upon itself, we just, whatever the output is for the first evaluation, we just re-input that in the exact same function. So g circle g of 5 here is equal to -1. Alright, so now let's look at composition of functions that are written algebraically. We have f of x is equal to 3x squared minus 1. G of x is equal to 5x plus 7. Let's make that a better 7. And then we have 4 different compositions. Let's do the first one together. So f circle g of 2, again what that means is f of g of 2. That's not how we want to write that. F of g of 2, like this. I'm just writing out this extra step here just for the sake of clarity. This isn't a necessary thing to do. If you can look at a composition like f circle g of 2 and know what the first step is, that's fine. Just so I'm clear though. So g of 2, we're going to plug in 2 into the g function. So g of 2 is equal to 5 times 2 plus 7. 5 times 2 is 10 plus 7 is 17. So now we're going to do we're going to do f of 17. So we take the output of the first one and use it as the input for the second function. So 3 times 17 squared minus 1. 17 squared, I think, is 289. Yeah, that checks out. Okay, so when we evaluate all of that, we end up with 866. Alright, so that's what our final answer would be, 866. Alright, why don't you pause the video and see if you can find the correct answer for the next 3. Alright, so here's the work for these next 3. For B, we get 137. For C, we get 1502. For D, we get 42. So that's a wrap for this video. So just remember the key things we want to be able to do are evaluate compositions of functions that are given in a table, in graph form, and then in algebraic form.